Hi everyone, welcome back to my channel. So today topic is one of the most important topic, that is chemical bonding. So what is chemical bonding? Actual force between atoms which can hold them together as a molecule or ion is known as chemical bond. Okay, actual force between atoms which can hold them together as the molecule or ion is known as chemical bond. So chemical bond formation is an exothermic process. Okay, chemical bond formation is an exothermic process. So for example, so H plus H, it forms H bond H. It is a isolated and it is a bonded. Okay, in isolated, stability low and the potential energy will be high, and the bonded one, the stability is high, potential energy low. That means stability proportional to 1 by potential energy. Okay, bond energy, bond. So what is bond energy? Release energy during chemical bond formation is known as bond energy. What is bond energy? Release energy during chemical bond formation is known as bond energy. So what is bond dissociation energy? Bond dissociation energy, required energy to breaking the chemical bond is known as bond dissociated energy. What is bond dissociation energy? Required energy to breaking the chemical bond is known as bond dissociation energy. That means hydrogen plus hydrogen, so bond will be formed. Energy released is called bond energy. Okay, it is negative charge. Energy observed, it is bond dissociation energy, it is positive charge. Okay, bond energy increase, attraction between atoms increase, bond strength increase, stability increase. So stability proportional to bond energy. Bond strength proportional to bond energy. Now the question is, consider the following transformation: 6H gives rise to 3H2, so that is delta H 600 kilocalories. On the basis of given in transformation, bond dissociation energy of the H2 molecule. In this question ask bond dissociation energy, okay, not bond energy. So the answer, release energy during formation of 3 molecules is 600 kilocalories. So 1 molecule is equal to 600 by 3, so it's cancelled, so 200 kilocalorie. So bond energy, if we case in this question ask bond energy, that is negative 200, okay, bond energy negative 200. Bond dissociation energy of H2 molecule is plus 200. So the answer is second one, okay. Next, cause of chemical bond formation. So to gain stability, atoms can form chemical bond. To gain stability, atoms can form chemical bond. An atom can gain stability by following 2 methods, okay. An atom can gain stability by following 2 methods. First one, to complete their octet, and next one, to decrease their potential energy. So mechanism of chemical bond formation. Next, mechanism of chemical bond formation. 2 types of forces act between 2 atoms during chemical bond formation, okay. 2 types of forces act between 2 atoms during chemical bond formation, that is HA plus HB gives rise to its form H2 plus AB. In He bond, Hp bond, it occurs repulsion, okay. So first one, attractive force. So what is attractive force? Nucleus of Hb, electron of Hb. The next one, nucleus of HB, sorry, HA, electron of HA. Second one, repulsive force. nucleus of HA, nucleus of HB. Electrons of HA, electron of HA. So in this case HA, HB. So nucleus of HA, nucleus of HB. So nucleus of HA, nucleus of HB, it occurs repulsion. Okay. The next potential energy theory of chemical bond formation. In this, it is the graph between internuclear distance and potential energy. Okay, it is the graph between internuclear distance and potential energy. So internuclear distance, potential energy. A, B, B, it is 4 angstroms, 6 angstrom, 8 angstrom, 10 angstrom and infinity. The potential energy 0, minus 10, 20, 30 and 40. In graph, bond distance, it is the bond length and it is the bond energy. Okay. So what is bond length? Internuclear distance where chemical bond will be formed is known as bond length. Okay, internuclear distance where chemical bond will be formed. So what is bond energy? Negative potential energy where chemical bond will be formed. Okay, negative potential energy where chemical bond will be formed, it is bond energy. Internuclear distance where chemical bond will be formed, it is a bond length. Okay, now take one example. So consider the following potential energy diagram. So this is the diagram. So positive, negative, 0 to infinity, AB and PQ on the basis of given group. Incorrect statement. Okay, not correct statement, incorrect statement. It is bond energy of PQ, BE of AB, BL of AB, BL of PQ. So stability of AB, stability of PQ. So bond dissociation energy of PQ and bond dissociation energy of AB. The incorrect statement is stability of AB, stability of PQ. So next, Lewis symbol. Okay, Lewis. What is Lewis symbol? Representation of outer electrons of an atom in the form of dot or cross. Okay, representation of outer electrons of an atom in the form of dot or cross. For example, carbon. Atomic number 6. Electronic configuration 1s2, 2s2, 2p2. So in outer electrons 4. Okay, so carbon 4 dots, 1, 2, 3, 4, or 1, 2, 3, 4. Okay, next, Lewis octet rule. Lewis octet rule. So it is important. So tendency of an atom to achieve 8 electrons in their outermost is known as octet rule. That means tendency of an atom of achieve 8 electrons. in their outermost shell is known as octet rule. So exception octet rule. So what is exception octet rule? Species which cannot follow octet rule at these are quite stable are known as exception of octet rule. So there are three types of species, that is duplicate structure species, electron deficient species, and super octet species. So first duplicate structure species. So species which contain two electrons in their outermost shell are known as duplicate structure species. So species which contain two electrons in their outermost shell. For example, hydrogen, H bond H, hydrogen 2 electrons, these hydrogen 2 electrons. So lithium H, form lithium plus H minus. Lithium atomic number 3, electronic configuration 1s2 2p1, that means 3. So cation, removal of 1 electron, that means 2 electrons. The hydrogen 1, atomic number 1, electronic configuration 1, anion adding 1 electron, so plus 1, 2 electrons. Okay, the next one, the second species, electron deficient species in which central atom contain more than 2 electrons and less than 2 electrons in their outermost shell are known as electron deficient species. Means in this duplicate structure species, 2 electrons in their outermost shell. In this electron deficient species, central atom contain more than 2 electrons and less than 2 electrons in their outermost shell. Okay, is known as electron deficient species. So the equation, outer electrons of central atom is equal to V plus B minus C plus A. So this is the equation. So V means number of valence electrons of central atom in free state. Okay, number of valence electrons of central atom in free state. What is B? Number of bond formed by central atom. So what is C? Magnitude of positive charge. So what is A? Magnitude of negative charge. So now we take an example. Example BeF2. So beryllium so atomic number 4. What is V? BCA. So V means number of valence electrons of central atom in free state, that is 2. B, number of bond formed by Ca, means 2 bonds are formed in beryllium. C, magnitude of positive charge, magnitude of negative charge, both are 0. So the equation is outer electrons of central atom is equal to V plus B minus C plus A. So the equation, so V 2 plus B 2 minus 0 plus 0, so 0 so cancel, so 4. Okay, so take another example, BCl3, so boron. So did you try this? V B C A. So V means number of valence electrons of a central atom in free state, that is 3, and B also 3 0 0. So is equal to apply the equation. So 3 plus 3 minus 0 plus 0 is equal to 6. In this electron deficient species is also called as hypovalent or electrophile or Lewis acid. The next species, super octet species. So species in which central atom contain more than 8 electrons in their outermost shell is known as super octet series. So for example, IF7. Okay, IF7, the iodine outermost electron 7. So plus fluorine 1, 7 fluorine 7. So that is the 14 electrons. So next SO3, so sulfur 6 outermost electrons plus oxygen 1 oxygen 2, so 3 oxygens plus 2 and 2, so 6. Okay, 12 electrons. Next XeF5 plus, so Xe 8 electrons plus how many fluorides? 5. So plus, that means remove 1 electron, so minus 1, that is 12 electrons. The next SF6 minus 2, so sulfur 6 plus fluorine 6, so minus 2, that means plus 2. Cation, so it is cation, it is anion, adding 2 electrons. 6 plus 6 plus 2, 14. PCl6, phosphorus 5 plus 6 minus means 1 electron, so plus 1, that is 12. Okay, next SOF4, sulfur 6, oxygen 2, fluorine 4, 12. Okay, XeF6, xenon 8, fluorine 6. Okay, so this is today class. Did you understand the concept? Like, share and subscribe. Thanks for watching. And if you want any particular topic, so if you comment, I will explain that topic. Okay, thank you.